Hello, welcome to Chapter 2. If you notice, the format of this video is a little bit different. I'm over here to the right of your screen, and the notes are here in the middle. Hopefully it'll be easier to see than me in front of the smartboard, because this way I won't cast shadows. So for this section, we're going to start 2.1, real numbers, and today's date, so whatever today is. And the I can statement, and what we hope to be able to do by the end of this lesson is that I can graph numbers on a number line and find absolute value. So, right here, I can graph numbers on a number line and find absolute value. So, to get us started, we're going to look at some vocabulary. The very first one is real numbers. And real numbers are any and all numbers found on a number line. Okay? So, real numbers are any and all numbers found on a number line. That's all the numbers in between the gaps and in between your notches. That's everything you could possibly graph on a number line is a real number. And real numbers have 5 subsets. Okay? So the 5 subsets are just groups within that big group. So the smallest group within real numbers is our natural numbers, and we call those our counting numbers. So think back when you're little and you're learning how to count. That's the numbers that come natural to you, like 1, 2, 3. Those are your natural numbers. So 1, 2, 3, dot, dot, dot for as high as you can count. Now after natural numbers are our whole numbers. And whole numbers are our counting numbers and 0. So how the first group started with 1, 2, 3, the second group is going to start with 0, 1, 2, 3, dot, dot, dot. So it's natural numbers plus 0. And now our integers are next. And integers are whole numbers and their opposites. Integers are whole numbers and their opposites, which means we're going to have negatives now. So positive and negative numbers. So if I go on like I have been doing, I will start with the negative number, so it'll be dot, 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 negative 3, negative 2, negative 1, 0, 1, 2, 3, dot, dot, dot. Because if you think about it, the opposite of positive 2 would be negative 2. So whole numbers and their opposites. Our next group is rational numbers. And it says terminating, which means it ends. So terminating or repeating decimals. And it's any number that can be written as a fraction. So if you think about a terminating decimal, that's like 0.5 because it stops. That's as far as it goes. And it says any number that can be written as a fraction. Well, I can write 0.5 as 1/2. Same way for a repeating decimal. If I write 0.3 repeating, well, that's the same thing as 1/3. And I can grab a whole number like 2 and say 2 over 1, so I can write a whole number as a fraction. Same way I can write an integer. I can take negative 3 and write it over 1. So rational numbers are anything that can be written as a fraction. That's the big one. And then our last subset is irrational numbers, and it's never ending and non-repeating decimals. And I always like to kind of mention that that means if you were to put an irrational number in your calculator, the decimal would never stop. So it would never stop. And when it says non-repeating, that means there's no pattern to find. Like a number might repeat once or twice, but there won't be a pattern to it. So never stops and no pattern. And numbers we like to use for irrational are pi, because pi is 3.14, and it's a real big decimal that keeps on going and going. We just recognize 3.14. Or like the square root of 2, because if you were to put that in your calculator, it would be a decimal that would be 1 point, and then it would keep going on, and it would never repeat, and it would not have a pattern. It would go all the way off your calculator screen. So that's an irrational. Our very last vocabulary word is not a subset, it's just a vocabulary word, and it's absolute value. Now, absolute value is a number's distance from 0, okay? And because distance can never be 0, absolute value can never be negative. So absolute value can never be negative because the distance is never negative. So this is the big part. Absolute value can never be negative because it's the distance, and distance can't be negative. Okay. Now what we're going to do next is kind of look at our number subsets as, I always consider this like the Russian doll, because if you've ever seen the Russian dolls, like those are like the little doll in the middle, and the bigger doll on the outside, and a bigger doll, and then a bigger doll. It's like when you open it up, the dolls keep getting smaller. Well, we're going to do that for our real number subset. So if you'll draw out this table in your notes, there's one really big rectangle here, and then inside the big rectangle, there's a smaller one in which this left side gets, the right side gets cut off, and the left side gets 3 more smaller boxes in it. So I'm going to give you a second to copy this into your notes, and this is going to be our real number subsets. Okay. I always like to start out with our smallest one and work our way out. So the one in the middle, this is our natural, because we said it's our smallest ones, our counting numbers. And now we're going to use a letter. So natural numbers we actually denote with the letter N. Okay? And we already said those were our 1, 2, 3, for as high as we could ever count to positive infinity. Alright, to the next group is whole numbers. So whole numbers is denoted by the letter W. And it is the natural numbers in 0. So it starts out 0, 1, 2, 3, dot, dot, dot. So if you notice, it's the Russian doll in the 1, 2, 3 in the natural numbers, and it's also in the whole numbers 1, 2, 3. The only thing whole numbers does is add in 0. Then integers is just bigger than whole numbers. So integers, and it gets denoted by the letter Z. And we say it's whole numbers and they're opposite. So if I look at my whole numbers, 0, 1, 2, 3, dot, dot, dot. And then say the opposite of positive 1 is negative 1. Opposite of positive 2 is negative 2. Opposite of positive 3 is negative 3. And it could go in the other directions. We have dots on both ends to show it's all the negatives and all the positives. So once again, our natural numbers are also whole and integers. They're in all these groups. Same way whole is also in integers. Now the group just beyond integers is rational. Remember, we said rational is anything that can be written as a terminating decimal, repeating decimal, or fraction. And rational gets denoted by the letter Q. And we said it was like if we have 0.5, and we said it's 1/2. 0.3 repeating is 1/3. We can even throw in a natural number of 2 and put it over 1. So natural numbers in all these groups now. So that's why it's kind of like a Russian doll. It keeps getting bigger and bigger and bigger. Now the one off to the side, he's all lonely because he's our irrational. Irrational stands off by itself. So the irrational gets denoted by the letter I. And we already said that's like pi square root of 2, square root of 5. And our biggest group, and the one that encompasses all the subsets, are our real numbers, and it gets denoted by the letter R. So all these numbers in here get denoted by the letter R. Okay, now we're going to make ourselves a little number line. So if you'll just write number line, and if you notice I have my number line here, just sketch this out real fast. I'm going to put 0 in the middle. 1, 2, 3, 4. And then off to the left, we have -1, -2, -3, -4. This is just another way to show our number subsets. Because here from 1 to positive side, so all the way to the arrow, that's our natural numbers. From 0 all the way out beyond the arrow is our whole numbers, because it includes 0. Then the whole, all these numbers that are labeled on our number line are our integers, and that's the letter Z. So kind of a different way to show you the subsets. So our very first example, you don't have to write out the instructions. You just need to follow along with me. So number 1 says, name the coordinates of the points graphed on each number line. Gives us a number line here. Now, all you have to do is make a brace to show that these numbers are what's identified on the number line. So the points that's first graphed, we just look for the ones with the dot. So we have -4, -3, -2, 1, 2. You just write those out. -4, -3, -2, 1, 2. And then we close it up. Oh, don't need that comma there. There we go. Okay, for the second example, we once again make our brace to show this is all the numbers in this group that are plotted on this number line. And we have 1, 1.5, 2, 2.5, 3. Now real quick, you see that this arrow is highlighted. So because that arrow is highlighted, we're going to have to put dot, 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 just so we know that the arrow shows it continues on to the right side. Same way the dot, dot, dot continues on to the right side. Show all the positive ones beyond 3. Okay, for these next couple of examples, we're asked to graph each set of numbers. So go ahead and make yourself out your number line for number 3. We're always going to put 0 in the middle for this one. And then where all these numbers up here in the subset, or sorry, in the set of numbers are even, to save myself a little bit of writing, I'm going to make a notch for 1 and then say 2, 3, 4, 5, 6, and then -1, -2, -3, -4, -5, -6. Okay. Now, I'll grab my red, and it says dot, dot, dot. So that means we want all the even ones to the left of -4. So we know we're going to have to put one -4. Then since the dots are on the left, we're going to have to put dot to the left. And also, because it's dot, dot, dot to begin with, I have to shade in this left arrow to show that it keeps going to the left. And then -2 is on here, 0, 2, 4, 6, and we're finished with that one. Now this next one, let's look at him, number 4. It counts by a denominator of 3, and it's all fractions. So we have -4/3, -1/3, 2/3, 5/3. We can actually count by thirds just as long as I keep it consistent. So I can make it 1/3, 2/3. Now I can't say 3/3 because 3/3 is 1 whole. And then 4/3, 5/3, and same way to the negatives. -1/3, -2/3. Remember, I can't say 3/3 because that is -1, and then -4/3. And because this one doesn't have any dots, I just come through and just say -4/3, -1/3, 2/3, and 5/3. And we're done with this one. There's only one left down here, number 5. And it says integers less than -3 or greater than or equal to 5. So I'm going to go ahead and put my 0 in the middle and count out my 1, 2, 3, 4, 5, and then -1, -2, -3, -4, -5. Alright, so it says integers less than -3. So here's my question, something you need to ask yourself. If it's less than -3, does it include -3? No, it doesn't. So I don't put a dot on -3 because it doesn't want -3. It just wants the numbers less than. Remember, less than is to the left. So I want all my integers, so that's all the whole numbers and their opposites, left of -3. So it would be -4, -5. I have to shade in this arrow to show that it keeps going beyond -5 to the left. And over here, it says greater than or equal to 5. So this time it says equal to 5. So I do include 5. And it says greater than. So if I made a 6 here, I would include 6. I also have to shade in this arrow to show it wants everything greater than 5, everything bigger than 5. So these are the number line problems. This last set is the absolute value. So this is example. Okay, with these absolute value problems, this is number 6, and it just says to find the absolute value of each. So it gives us the absolute value of a -7. Remember, absolute value means a number's distance from 0. So if you think about a number line, -7 is 7 places away from 0. So it can never be negative, so the absolute value of -7 is +7. They made down here for number 7. We have the absolute value of 7/9 and the absolute value of 7/9. Well, it's 7/9 away from 0. And once again, positive absolute value still is positive. So absolute value always gives you a positive. And the very last example, number 8, says evaluate 15 minus the absolute value of x plus 4, and then x equals 8. So very first thing we have to substitute, 15 minus the absolute value, x is 8, plus 4, absolute value bar. Now here's one quick thing. You have to treat the absolute value bars like a parenthesis because they group. Remember, that very first step of order of operations isn't just parenthesis, it's grouping. So because absolute value is grouping these two numbers, I have to do them first. So I have to just drop down my 15 minus and say 8 plus 4 is 12. So the absolute value of 12. And then I have to then still work with my absolute value bar, so they're still grouping, and say, what is the absolute value of 12? The absolute value of 12 is 12, so 15 minus 12. 15 minus 12 is 3. There we go. We're finished. Once again, quick reminder that if you need to see anything again, or if you didn't get any parts, just rewind, go back, rewatch them. There will be a notebook check in the morning, so be prepared. And I guess afternoon for 7th period, sorry. So there will be a note check tomorrow. And if you have any questions, please ask. Thanks.